100% disk usage silently crashes Dockerd and blocks all CI/CD builds. Here's exactly why. The root partition fills up, the daemon can't write to its state, it crashes, the socket drops, and every pipeline fails. Let's break down how to fix and prevent this. Welcome to TheCodeForge. Before we dig into that production issue, let's cover cannot connect Docker daemon. The error means the Docker CLI cannot reach the daemon through the Unix socket. The daemon is the background service that manages containers, and the socket is the communication channel. When the socket is missing, inaccessible, or the daemon is not running, every Docker command fails. There are 5 primary causes. The daemon is not running, the user lacks socket permissions, the socket file is missing, the disk is full, or the environment is misconfigured. Each requires a different fix. Here's a Python diagnostic class that checks each component systematically. It returns a report with status, details, and fix commands for each issue. On Linux, the most common fix is to start the daemon and add your user to the Docker group. But always check disk space first. A full disk is the one cause of daemon crashes. This bash script runs through the steps in order. Check installation, start the daemon, verify the socket, add user to group, and check disk space. Run it on any Linux host. On macOS, Docker Desktop must be running. On WSL2, use Docker Desktop's WSL integration. Never install Docker Engine inside WSL2. The socket is provided by Docker Desktop. This script checks if Docker Desktop is running on macOS and starts it if needed. For WSL2, it verifies the socket and reminds you to enable WSL integration in Docker Desktop settings. Preventing daemon crashes in production requires 3 strategies: systemed watchdog for auto restart, automatic disk pruning, and disk usage alerting. These ensure the daemon recovers without manual intervention. This script sets up the 3 prevention strategies: a systemed watchdog that restarts the daemon if unresponsive for 60 seconds, a weekly cron job to prune old images, and a disk alert that checks every 15 minutes. The socket is owned by root, Docker with permissions 660. Only root and Docker group members can access it. This is a security boundary. Adding a user to the Docker group gives them root equivalent access. Never add CI users to the Docker group. Use TLS or Dindy instead. Always verify the socket exists and has the correct permissions. The expected output is srwrw1 root Docker. If permissions are wrong, the daemon may not start or users can't connect. Docker ships with 2 systemed units, Docker service and Docker socket. The socket unit activates the service on demand. If the socket unit is not running, the service can't bind. Always enable both and start socket before service. This Ansible task ensures both units are active and started in the correct order. Never just start the service, always enable the socket first. On WSL2, you can have 2 Docker daemons, one from Docker Desktop and one installed inside the distro. This causes socket conflicts. The fix: use only Docker Desktop's integration and never install Docker Engine inside WSL2. Check which socket is being used and set the context to default if using Docker Desktop. The expected output shows 2 contexts, default and desktop Linux. This is the same issue we highlighted at the start. Here's exactly why that 6-hour outage happened. The build server's root partition reached 100% disk usage due to accumulated Docker images and build caches. When the disk filled, the Docker daemon crashed because it could not write to /var/lib/docker. The system service entered a failed state and did not auto-restart. No monitoring existed for disk usage or daemon health. The fix was straightforward. Recover disk space by running Docker system prune af volumes, which freed 80 GB. Then restart the daemon with sudo systemctl restart docker. To prevent recurrence, add monitoring, a cron job for disk alerts at 80%, a systemed watchdog, and automatic weekly pruning. Running every Docker command with sudo is a security risk and breaks scripts. The fix is to add your user to the Docker group. After a server reboot, Docker is not running and all containers are stopped. Always enable Docker to start on boot with systemctl enable Docker. Disk exhaustion is the one cause of daemon crashes. Monitor disk usage and set up automatic pruning to prevent silent failures. The article focuses on system-based Linux, but many production environments use initd, upstart, or container-optimized OSes like CoreOS or BottleRocket. On those systems, the daemon is managed differently and the socket path may vary, e.g., run docker sock. Always check the init system's documentation for the correct start-restart commands. Rootless Docker runs the daemon without root privileges and uses a different socket path, typically xdg runtime dir docker sock, e.g., run user 1000 docker sock. The error cannot connect to the Docker daemon in rootless mode often means the Docker host environment variable is not set or the socket is missing. Use export docker host equals Unix $xdg runtime dir /docker sock to connect. In CI/CD pipelines, adding the CI user to the Docker group is a security risk because it grants root equivalent access. A safer alternative is to use a Docker socket proxy, e.g., Docker socket proxy or bobcubcow/Docker socket proxy, that exposes a limited API over TCP with TLS. This prevents container escape while still allowing builds. When you get the error, run these commands in order to diagnose the issue. Check daemon status, socket file, user group, and disk space. The logs tell you exactly why the daemon failed. Let's run through some common interview questions. What does the error mean? CLI cannot reach daemon via socket. How to diagnose on shared server? Check daemon, socket, group, disk, config. Design monitoring system, watchdog, disk alerts, health check, socket config. And a few frequently asked questions. Why do I need sudo? Socket owned by root, only Docker group can access. Is Docker group a security risk? Yes, equivalent to root access. Can I change socket path? Yes, via daemon, JSON, or Docker host. To summarize, the error means the CLI cannot reach the daemon. Always check 5 components: installation, daemon status, socket, permissions, disk. Disk exhaustion is the one cause of daemon crashes. Use systemed watchdog and automatic pruning in production. Ready to go deeper? Up next, introduction to Kubernetes, then Kubernetes architecture explained, then Kubernetes pods and deployments. Find them all at thecodeforge.io. Thanks for watching. The full article and code examples are covered in detail at thecodeforge.io.